Some signals answer questions. Some confirm everything scientists have spent decades trying to understand. But every once in a while, a transmission arrives that seems to shatter everything we thought we knew. Imagine staring at a monitor as data pours in from a spacecraft that has been traveling through the darkness for nearly half a century. Then imagine realizing that what you're looking at doesn't resemble anything ever received before. The room falls silent. Conversations stop. Suddenly, every assumption about deep space is called into question. That is exactly why Voyager 2's latest transmission has captured so much attention. For more than 46 years, this remarkable spacecraft has continued its lonely journey farther away from Earth than almost anyone ever imagined possible. Throughout that time it has faithfully sent back measurements of plasma, magnetic fields, and the strange environment beyond our solar system. But this latest signal appears different. Instead of the familiar stream of engineering data and natural background noise, researchers noticed faint patterns hidden within the radio signal itself. The pulses appeared organized, almost rhythmic, emerging from one of the weakest transmissions ever received across more than 12 billion miles of space. What makes the discovery even more surprising is the timing. Not long before this transmission, Voyager 2 experienced a lengthy interruption in communication after engineers worked tirelessly to restore contact following antenna alignment issues. Every instrument aboard the spacecraft has already exceeded its original design life, and many experts believed the probe was approaching the limits of what it could still accomplish. Yet instead of fading into silence, Voyager sent back another message. And according to those analyzing the data, this one carried characteristics unlike previous transmissions from the spacecraft. The signal arrived from a region where the sun's influence has almost completely disappeared. Beyond this boundary lies the true interstellar environment, a place humanity has never explored except through the aging Voyager probes. Whether the unusual patterns represent natural phenomena that scientists have never encountered or simply effects that are not yet understood remains an open question. But one thing is certain: the data has renewed interest in one of NASA's greatest missions. To understand why this latest transmission is so fascinating, we first need to go back to where the Voyager story began. Its origins trace back to an extraordinary cosmic coincidence that occurs only once every 176 years. During the mid-1960s, a young graduate student named Gary Flandreau discovered something remarkable while studying planetary motion. Jupiter, Saturn, Uranus, and Neptune were slowly moving into an alignment that would allow a spacecraft to travel from one giant planet to the next using gravity as a natural slingshot. Instead of requiring decades upon decades to reach each destination individually, a single mission could visit all 4 outer planets within a much shorter period. NASA immediately recognized how rare this opportunity was. The agency began designing 2 spacecraft that could take advantage of this once-in-a-lifetime alignment, using each planet's gravity to accelerate toward the next destination before eventually escaping the solar system itself. Those spacecraft became Voyager 1 and Voyager 2. What no one fully appreciated at the time was that this rare alignment would eventually carry both probes far beyond the planets, sending them into a region of space that had never been explored directly by any human-made object. The same gravitational pathway that enabled the historic Grand Tour also opened the door to humanity's first close encounter with interstellar space. Voyager 2 lifted off on August 20, 1977. At first glance, it hardly looked like a machine destined to make history. Wrapped in golden insulation and powered by radioisotope generators, it relied on computer systems that possessed far less computing power than even the simplest modern electronic devices. Yet despite those limitations, the spacecraft accomplished feats that transformed planetary science forever. It survived Jupiter's intense radiation, navigated safely through Saturn's complex ring system, revealed astonishing discoveries at Uranus, and became the only spacecraft ever to perform a close flyby of Neptune. During its historic journey, Voyager 2 discovered new moons, examined unfamiliar ring systems, observed violent storms, detected enormous atmospheric winds, and uncovered mysteries that scientists continue investigating today. When its planetary mission finally ended, its cameras were switched off forever to conserve precious electrical power. From that moment on, Voyager's mission entered an entirely different chapter. Instead of photographing distant worlds, it became humanity's lone observer at the edge of the sun's domain, quietly sending back measurements from an environment no spacecraft had ever sampled before. Every signal it transmitted offered another small glimpse into the unknown. And with each passing year, those whispers from the darkness became increasingly valuable.